to f prime and integrate, you get to f. You start at f and take the derivative, you get f prime. So this is really both. So I can look at it this way and say, like, okay, what's the integral of both sides? That way. Or I could look at it this way and say, what's the derivative of both sides? That way. You do have to know both. Like in the problem we're about to do next week, maybe you have to be able to take the derivative and integrate in the same problem. Gateway, I think I had said at some point last week, the gateway would be toward the end of this week. We're not going to make it there in time. So that's fine. We slow down. That's fine. It'll be next week sometime. Monday. No, I wouldn't make it Tuesday. No. Because you win regionals every time. You're picking up your own success.
I'd rather Thursday, Friday, Monday. I'd rather Friday, Friday. Yeah, Friday, Monday. Oh, yeah.
That's cute how you guys think of it.
I don't know. I'm not going to tell you that. I'm just say that this
Gotcha.
You're lucky we'll see this. I'm a lifeguard.
Go to 6-8.
Yeah, nobody saw it.
What?
Nobody saw it.
Oh, that was COVID here. Your head was up your buddy.
I just look at myself and I'm like, I hate you. You need to change.
Okay. So we've basically done this like top part here, where we talked about like the derivatives of all of these things are 2x. So they can all be integrals of 2x, and we don't know what that constant is, so we put a plus c. And for now, unless I give you the right information, you can't find out what c is, but we're going to find it today. So I think you'll be happy. All right, integrals without a boundary are called indefinite. And that's when you get the plus c. If it's a definite integral, that's when you have like the numbers there. You plug in and your answer is just unknown. You plug in this minus plug in this, and you get like 12, and that's the error. Indefinite, you're finding equations. So part of this is knowing what an indefinite integral is. We kind of covered that. Part of this is that giant sheet of derivatives and integrals I just gave you. There's not much I can do for you for that, right? Like you just got to kind of know them. I don't have any magic memorization tricks. But there is one new thing in this lesson too. So find the general solution of integral of 7x. Well, the integral of a to the x is 1 over the natural log of a times a to the x, and then you would put your plus c. So the integral of 7 to the x is just 1 over the natural log of 7 times 7 to the x plus c. So that's just applying one of the rules, applying one of the derivative definitions that you got to know. How many made a like flashcards or a Quizlet or some similar thing? Okay. All right, second one. We're going to find c here. Very exciting. So this is saying find the particular solution. So when you find the plus c, it's a general solution. So let's look at this. If I integrated 2x, yeah, that's fine. If I integrate 2x, that gives me x squared plus c. Graphically, what that looks like is, well, it might be that x squared. It might be that x squared. It might be that x squared. It might be like x squared minus 1. It might be x squared minus 3. It might be x squared minus 4. Those are all potential solutions. What this does is give you a point on the curve. It's like, okay, I know that you have the general solution. Now I know it goes through that specific point. Now can you find out what C is? And find out like which one of these is actually what we're working with. And that's what we can do in number 2. So we're going to start off by, we have the derivative. So I want to get to f of x. How do I go from f prime to f? Integrate. So I'm going to integrate e to the x minus 2x squared. That is an indefinite integral because there's not numbers to plug in. So I'm going to get a plus c at the end. But this one gives me enough information to find this. So the integral of e to the x is e to the x. This would be power rule, so add 1 to the power. Divide by the new power, so you'd have like 2/3 x to the third. Plus c. And that equals your f of x. Or if you want to call it y, it's the same idea. Call it f of x or y. And then what they give you is 0 is your x value. 4 is y or f of x. Plug those in and you can find out what c is. So I'm going to plug in 0 for x and 4 for y. So I'll have e to the 0 minus 2/3 times 0 to the third plus c. I don't know c still. That's my goal. That's what I'm going for here. Equals y or f of x, whichever you want to say. No, sorry. What is y or f of x? 4. So we solved that for c. So what's anything to the 0 power? 1. That's just nothing. So 1 plus c equals 4, which means c equals 3. So the way you write the solution is you go back and like rewrite this. So you're like smarter than you were 20 seconds ago, and now you can put 3 there. So the actual answer is y equals e to the x minus 2/3 x to the third plus 3 because I went through and found out, okay, I know that point's on the curve. That means C has to be this. And that's called a specific, or a particular, or a specific solution. Questions on that one? Does that make you feel happy? Yeah, that's what? What's your soccer number?
You so want to ask why. In some cases, we could see
Sure. But in a second. I do. Okay. 1 over x or x to the negative first, like those are the same. Your derivative will be the natural log of the absolute value of x plus c. You can't take the natural log of a negative. So you need those absolute value signs there because if you are plugging in a negative, you need the function to make it positive so you can actually do it. If you just put ln of x, it's not right. So if I look at 3, I don't think most people would really do it this way, but just for explanation purposes. That's what's really happening. And then even more kind of showing steps that you may or may not write is I'm going to pull that 5 out. Now I can just integrate like what's there. So remember this always tells you what variable you're in. So what's the integral of 1? Like when you take the derivative of to get 1 is x. Minus 5 times what's the integral of 1 over x? Well, it's that. And then you put your plus c. So I don't know what that looks like, but that gives you like, it could be this or this or this or this or this. And they didn't give us any information to say like find the specific one. So right now I just know it's like one of those curves. In 4 they give me enough, but let me slow down versus 3, okay? Alright, 4. So that's the derivative. So f prime, I want f, so I'm going to have to integrate. While I'm like rewriting the integral, I don't want variables at the bottom. I don't know how to integrate that way. up. So it's like 2x to the negative 1 plus 6x to the negative 2 times dx. And then I got to integrate those. And this is easy to forget. So, like, very often, it happens to me sometimes. I'll be like, okay, I'm going to add 1 to the power, because you're just so used to, like, the power rule. I'm going to add 1 to the power, what would I get? 0. And then I divide by the new power. Well, you can't divide by 0. It, like, breaks. So at that point, I'm like, oh, that's right. It's natural log. So that happens to me sometimes. That's kind of a nice clue, because you're like, oh, crap, that way it won't work. Hopefully that jogs your memory. That's ln. So this would be 2 times ln of absolute value of x. Add 1 to the power here would give you x to the negative 1. Divide by the new power is negative 6. Plus c equals y. So I have a general solution, which means it's just a list. It's like a vertical stack of like different equations it could be. Then they give you a point, and they're like, this is the point on the graph. Now figure out what c is. So plug in 1 for x and negative 7 for y. And then we got to solve this for c. So natural log of 1, remember natural log. What's really down here? Not for natural log. For log it's 10. For natural log, it's an e. And what you're looking for is e to what power gives you 1. So natural log of power, and it's just saying what power would give you 1. What power always gives you 1? 0. So 2 times 0, this is nothing, that doesn't matter. That just goes away. 1 to any power is 1. So this is like negative 6 plus c equals negative 7. I would add 6 to both sides. So c equals negative 1. And then you just gotta like put it back in. So I'm rewriting that this was the general solution, but I can write the particular solution now because I know what c is. So that would be the answer that they want, the particular solution. How's that one, Steve? Questions? Still right. I like getting your way. Alright, trig. So I just gave you the sheet. Do you want me to write them up here? Do you want a second to write them down there? Should we just like move on to the sheet? Reference? Let's write them on there? Alright, let's write them on there. First person to talk gets their way. So the integral of cosine. So this is reading your sheet backwards. This side, and these would all have a plus c next to them, right? Integral of sine, negative cosine, integral of sec squared is tan, integral of cosecant, cotangent is negative cosecant, this one's secant, and this one's negative cotangent. Remember, if it starts with a C, the derivative is negative. That doesn't really work for integrals. If the integral has a c in it, the sign changed. That kind of. Anyway, number 5. So 3 secant squared of x. Is this an indefinite or a definite integral? This is indefinite. Definite's when you have a number. It'd be like from pi to 2 pi or something. You have to plug in and get a number. This is indefinite because we're going to get a curve, and we're just not sure is it this curve or this curve or this curve or this curve. So you don't necessarily need to show this step, but that 3 can factor out. And then what's the integral of sec squared? It's tangent. You put your plus c. At 6, now we're getting the particular solution. And now we got some trig in there, which I know a lot of people find a little more challenging than just normal stuff. It's presented a little bit differently. Instead of saying f prime, they said dy dx, but that still means derivative. So I have the derivative and I want to go to the original. So how do I go from derivative to original? Integrate, right? I'm going to integrate 1 minus sine of x. And it's indefinite, so there's going to be a plus c afterwards. But then they gave me this information where this is x and this is y, and I'll be able to plug in and find out what c is. So the integral of 1 is x. The integral of negative sine is positive cos. And sometimes it's helpful to like check it going backwards. Like make sure the derivative of this is this. Like is the derivative of x 1? Yeah. Is the derivative of cosine negative sine? Yeah. It's easy to mess up these signs. And then plug in what we know. So pi plus cosine of pi plus c equals pi minus 2. I can cross these out, right? I got a pi on both sides, so if I just like subtract pi from both sides, that'll go away. So I really have cosine of pi plus c equals negative 2. So pi, like from your perspective, pi is over here, cosine's the x values, so what do we got? Negative 1 plus c equals negative 2. So if I add 1 to both sides, I will get c equals negative 1. And then you just go back and rewrite this in a more accurate way. I'm kind of out of room, so I'm going to be a little bit lazy. Now that's a negative 1. How are those two? Right. Inverse trig derivatives. Everybody's favorite. They're on your sheet, but I can write them up here again. So this is 1 over the square root of 1 minus x squared. This is 1 over the absolute value of x times the square root of x squared minus 1. This is 1 over x squared plus 1. So the ones they gave you are literally just the actual definition. Usually when I see these on AP test, I'll show you in a second. There's a constant there. But it's not that big a deal. So what's the integral of this? Sine inverse, right? It's just that. So the derivative of sine inverse is this, which means the integral of this is sine inverse. Good luck. Next one. It's just secant inverse, right? So that's just that one. Plus c. What they'll usually do to make it like a little harder is they'll put like a 4 up here instead of a 1. And then all that would happen is you'd have a 4 there also. Because it could be like factored out, you do the problem, you put it back. So if there's a different number on top, it just like stays. And then 9 and 10 is like just different techniques. We have done both of these. Right.
When you take the derivative of it,
The derivative of secant inverse is positive. What?
On the sheet, it has the cosecant inverse as positive, and the secant inverse as positive.
yeah, I was looking.
Oh, damn. So see that on the sheet, I messed up. Remember it starts with a C, it's negative, right? So on the bottom where it says cosecant inverse, I made it positive. It should be negative. And then the secant inverse should be positive. I kind of cut that bottom part off too, but I think you can tell what it is from like part above it. No, I didn't know that. Everybody got that? Did I mess that up? Fix on the sheet I gave you? Because I don't want to hear on the gateway when you wrote the sheet wrong. Like, This is me fixing it. So yeah, we gotta tell Gabby. Okay. Number 9, separating rational functions. There's no quotient rule for integration, but this is the idea that you could separate these into 3 separate things. So it'd be like 3x squared over x plus x over x minus 2 over x. I don't know if you remember, but we had a couple of these like a few days ago. And when I got to here, I was like, oh yeah, we can't do this yet. But now we can, because we hadn't learned that ln yet. But we can now. Some of you I remember did it. Just kind of remembered. Well, this would be the integral of 3x plus 1 minus 2x to the negative 1. And then you just do it like a normal integral. But so I'm trying to emphasize this part here. If you have a bunch of stuff on top and one thing on the bottom, it doesn't work if there's more than one thing. You can just divide all those things by that. I'm sorry, it works if there's more than one thing, it's just not helpful. It doesn't do anything. So now I integrate this. So add 1 to the power, divide by the new power. That's 3x squared. What's the integral of 1? X. What's the integral of x to the negative 1? Well, I'm going to add 1 to the power, that's 0, divide by the new power. Oh wait, I can't divide by zeros. That's right, that's not the power rule, that is ln. So the minus 2 is still there, ln of absolute value of x, that's plus c. Is that okay for that? That method? What's up? How did you say wait? We're good? Okay. 10 I don't think is anything crazy. You would just distribute first. There's no product rule for integration. So that would look like, if that were derivatives, I would think product rule. Although I still would probably distribute it first. Just reminding, I don't think most of you would probably show this step, but just reminding you that square root is the 1/2 power. And when you are multiplying the base, what do you do with the powers? Add them up. So if I distribute here, that'll be 3x. 1 plus 1/2 is 3/2. And then 3x to the third times dx. And now it just looks like a typical problem. I can use my regular power rule and everything's fine. So I'm going to add 1 to the power here. What's 3/2 plus 1? 3/2 plus 2 more halves, so 5/2. Multiply by the reciprocal, so 2/5, but there's already a 3 there. So it's 6/5. That came from 2/5 times the 3 that was already there. Plus, add 1 to the power, so x to the 4th. Either divide by the new power or multiply by the reciprocal. This will be 3/4 now. And then plus. Question on any other notes? Yeah. 2/5. So I was here. I add 1 to the power to make it 5/2, and then the reciprocal. But then I multiplied that by the 3 that was already there. You good? Other questions? Okay. I'm going to save that question. I like how you bring it up every day. It sounded sarcastic. Alright, you guys are going, you're doing the whole thing, so 1 through 18. Oh, sorry, no. You're doing the whole thing, so 1 through 20. Test problem